But I figured a topic, just kind of thinking about this last week a little bit, something to be applicable to the whole group. Doesn't matter what facet you work in technology or are planning on working in technology. What we'll go over here, I think, is good for everybody to have an understanding of. Some of you probably know it deep, and others this might be new to you. But I imagine when we're done, you'll have a good idea, conceptually, of what SD-WAN is trying to accomplish. So we'll get into it. Now, one of the things I mentioned earlier was that I do work for this, big letters, right? This presentation is one that I've kind of given quite a few times. It is usually geared as a sales pitch. This, I've changed a little bit to be a little bit more vendor neutral. And really what I want you to get out of it is more so, hey, how is this relevant? How is it relevant for maybe the company I work for, or even the church that I go to, or how is this being received in the marketplace, and what's the attraction? To be honest with you, SD-WAN at first time I saw it many years ago, I thought it was smoke and mirrors, and we'll get into that a little bit. So what we'll do too is we'll break it up. I don't want to PowerPoint you to death, so if you have questions, throw them at me. We'll go over some slides, then we'll break, and then we'll get into the meat and potatoes of a demo that'll really kind of pull it together for you as far as what's taking place. But if I were to say kind of one of the highlights of SD-WAN and what it's trying to accomplish is some of the challenges that enterprises or businesses, organizations face as far as WAN and how you optimize your WAN, visibility. In SD-WAN, there's quite a few things to kind of add to that.
Could you start by saying what the S and the D stand for?
Yes. So the S and the D, what it is software-defined WAN. A little bit of background and why I kind of know a little bit about this is I work for a telecommunications provider, and SD-WAN is introducing more software into the way networking takes place and the choices that are made from the routing perspective. There's a lot of software integration taking place now on the telco side, and if you saw behind the curtain, you'd be stunned to see how little in the past there's been of that software integration. And it's a little bit of catch-up, right? It's a little bit of efforts that were done in data centers have now kind of moved into the telecommunications space and increased efficiencies. I work as a product manager for a telecommunications company that primarily works with businesses and other telephone companies. I first saw SD-WAN as a threat to my bread and butter, which is delivering circuits to customers. Because what it's really doing is it's allowing for multiple alternatives from a circuit or service delivery standpoint. Why I said earlier that I saw it as smoke and mirrors previously is a lot of what I saw, the challenges that it was overcoming, you could accomplish really early on with a firewall. I could create an IPsec tunnel and pull in a location into a network securely. What some of the optimization factors really dive pretty deep into what you can do. Because previously, if you go to your telco provider, let's say you get a 100 meg fiber circuit delivered, and you go, geez, you sold me this 100 meg circuit. 2 years ago, I had a 10 meg circuit that seemed to work just fine. 5 years ago, I had T1s. And what gives here? Why am I eating up all this bandwidth? And there's reasons for it, right? We all know that Facebook, YouTube. Netflix, YouTube. And when we get into that, we'll probably see some startling or maybe not so startling aspects of visibility and analytics of what's really happening in the workplace, right? But what it does is it gives some visibility at the service provider level, but then also from a multi-tenant component down to your network admins can see, hey, out of my 8 locations, and this one in particular, what's really driving all this traffic is this application or this particular end user. because you have that visibility at a granular level. Previously, if you asked a telecommunications provider for some of this information, they'd say, well, that's on your end, you go figure it out. I mean, they'd say it nice, but it'd be, I could show you some graphs of how much bandwidth you're consuming from an ingress and egress standpoint, but I'm not necessarily going to get to that granular level of what applications are consuming that bandwidth, and what users and what devices, whereas you can do that with the software. Consistent security. So security is always, for our salespeople, it's blood in the water every time that there's a ransomware attack or something like that takes place. Unfortunately, they love hearing about what happened in Atlanta recently and previously. Here in Charlotte, where they've had this vulnerability and ransomware attack, and now the data's locked up, yada yada. This isn't going to necessarily protect you from ransomware, but it is covering some different aspects of end user traffic. Particularly when you have like vendors accessing into the network remotely, or if you are tying together a remote warehouse that you've only got broadband delivered to and you're trying to pull it into an MPLS network. What it's allowing for is 128-bit, 256-bit encryption via multiple IPsec tunnels. And you see how these different applications are performing. We'll show all of what the visibility aspects of that look like. But what you can really see is, I'm sure we've all experienced, one thing that makes up my daily livelihood is hosted voice, and they call it hosted voice because the really previous name to that of VoIP had a bad name, because 10, 15 years ago, I think all of us went up to Best Buy and bought a little box for Vonage, plugged it in for $10 or whatever, and then you realize that anyone you talk to sound like they were underwater or broke up speech and all of that. And the reason being is at your home on your broadband, it's competing with all this other traffic. Then when it gets out on the internet, there's certain bottlenecks that exist that aren't as prevalent today that couldn't offer quality of service, which is how those services are being delivered and doing it with confidence level. With this, you're getting granular with that. So there's a lot of stats, analytics that'll show you jitter, packet loss, latency, which are kind of the primary components of a MOS score or an application performance delivery, whether that's video service, voice service, or some business critical application. Cloud-ready architecture. I can tell it's a marketing slide that I pulled from, but cloud-ready architecture. So what's telecom's a little slow to react sometimes, and when you start thinking about where does your data reside today, telecom mindset is you've got servers in your prem, right? And then when you started seeing more so of co-locations, data centers, data replication to the data center, as well as services like Azure or AWS, BlueJean, Salesforce, yada yada. They're a little slow to react to that. They're catching up. With SD-WAN, you can have some efficiencies in place there to deliver to those cloud services. What's really critical, right? I mean, sitting in the audience listening to a lot of different presentations on these cloud services, the biggest thing that I always hear is, yeah, it's great, it's got all these bells and whistles, but it's so slow, or there's reactionary times, or replication takes forever. And usually that's because of the network side of things, not necessarily controlled by that software solution. So here we go. This is a set of foundation of what the heck are we talking about? What is SD-WAN? So there's a couple components that you need kind of as a foundation here before we get deep into it. So the three components of SD-WAN is an orchestrator. An orchestrator isn't just something that you see in SD-WAN environments. You're seeing it in a lot of these other solutions that are coming out where they have where orchestration taking place. Orchestration, what that actually is doing in an SD-WAN environment is you've got the traditional telecommunications customer MPLS network. Does everybody, do most of you have an idea of what MPLS is? First off with that? Y'all, okay. So MPLS is when you're looking at like your community bank. They have an MPLS network that's supporting all of those branches, connecting back to a headquarters, connecting back to a data center. It's a secure way for them to keep that traffic off of the public internet from a security standpoint. So orchestration talks to what is known as like gateways, as well as an edge device. Your edge device is a CPE. Now, when I say CPE, customer premise equipment, or will be a router. When that comes online, in order for it to know how to connect back up to the network, the orchestrator says, I see you come online. I'm going to get a secure connection back to the gateway. So it sees this come up live and makes that connectivity or that handshake from access to the network.
Where does this orchestrator reside?
So it depends on deployment. So there's quite a few different vendors out in the marketplace today. We'll go over some of the common ones. The orchestrator depends on the solution. Majority of them out there that are replicable, what they're doing is they're putting it in like an AWS, they can put it in Azure, they can put it in a cloud environment. Most often, when we were from working as a product manager and vetting multiple vendors, most of them had an AWS as far as the orchestrator is. And actually, before I learned more about it, I wanted to put it in a data center that we were in. However, there's actually some downside to that from a redundancy standpoint. It's better off really having it live in like an AWS. But you'll see it also in private data centers as well. You usually want that orchestrator somewhere that's got high reliability. You hear about 5.9 reliability, and it's got all the bells and whistles there of redundant power, redundant links into it. The gateway is the hook into what's kind of like the service provider network. And that usually is in line or right next to core routers. So we'll have high capacity circuits connecting from the gateway to this is telco's routers. And that orchestrator is really kind of that provisioning element that says, you come online, I'm connecting you here. And this is also what's capturing, putting up the customer portals that will show in a minute, and pulling together some of the analytics aspects of customer traffic. So yeah, it's anything orchestrator, gateway, edge. But what it's allowing for too is traditionally if I had like an MPLS network, and this is where this scared me from coming from a telco background, is usually pay a premium for an MPLS circuit. They're not cheap. And they're usually fiber-based circuits. Yes, we still allow connectivity via T1s or kind of some of the legacy connectivity, but you don't see like traditionally like broadband or LTE tying into an MPLS network. This will allow for those alternative mediums to connect back into the network and add in that layer of security. Another thing that it's kind of doing is it's agnostic again from that connection. So what you've already seen as a result of this is some of those fiber high-priced MPLS circuits have calmed down in price as a reaction to alternative connectivity. And I'll just give you kind of an example. So let's say like I had a DS3. So, yeah, a DS3 is a good example. So the DS3 has an optical circuit, right? It allows for 44 megs of transmission. It's changed dramatically as far as rates, but that 5 years ago was a $5,000 a month circuit. Today, that circuit probably costs $500 a month. So you can kind of see some of what's going on there. Another example would be like a 100 meg circuit, 100 meg fiber MPLS circuit. Usually goes for anywhere between $700 to $1,000 monthly. But you think about that 100 meg circuit, what are you getting? 100 meg up, 100 meg down. Broadband is usually considered asymmetrical as opposed to symmetrical. So a broadband 100 meg circuit may get like 100 meg down, but your upload is significantly low. 100 meg by 10 meg. When you look at consumption patterns of customers, a lot of their traffic is download, not necessarily upload. So a lot of times that would work just fine as a transport. When taking consider with SD-WAN, that 100 by 10 meg circuit, you're going from that, like I said, $700 a month price point down to 100 to 200 a month, right, for the actual circuit component. So that's what scares me because I used to sell $1,000 circuits and now they're not worth as much, right? But with SD-WAN, the ones that are really consuming are using multiple different mediums, whether it's fiber, MPLS, traditional, or broadband, 4G, LTE. We're all consuming bandwidth, and we're consuming it at a large, significant rate. Just as an idea of how much we're consuming of bandwidth, part of my duties at work are looking at projecting and figuring out where we have to peer with other internet providers and forecasting bandwidth consumption. Each year, it's kind of like how your computer is. The Moore's Law kicks into effect. Bandwidth consumption is usually 1.5 times the amount of the year previous, which is kind of interesting. Another thing that's interesting is we can project every time that 1st of January rolls around. That week, we see an increase of 10 to 15% of bandwidth utilization. You go, well, what's that all about? Why is that?
Vacation.
Well, it's people on vacation. But actually, what a lot of it is people are getting their gizmos, their new gadgets that can do more from a throughput standpoint, and they're consuming more. In steady state, it's not like it just jumps up and then goes back down. You see some of these patterns, and it's interesting how it goes. We will always kind of need more and more bandwidth is the way it looks today. Oh boy, this one gets a little long. But this, I just kind of want to show it. I don't necessarily want to talk through it. We'll see some examples here of how this all kind of ties together, but you're really kind of easing a lot of things from an operational standpoint, monitoring aspect. You're getting a lot more visibility as an end user as well. Before, you're really kind of reliant on the service provider and your own internal tools to let you know what's going on with the network. I think most of the year have been at some point in your career where you're on call. If you're not in that status right now, I envy you. An on-call thing is, I know many times of being out to dinner Friday night with my wife, and trying to escape just for a minute, and then the phone call comes in, or I see an alarm come in saying, something's down, something's out, and then I have to race back home, log onto my laptop, and VPN in, and then try to diagnose what's going on from a network perspective.
I have a question.
Yes.
Is the vendor providing the transports, or does the customer have, okay, I'm going to buy an MPLS circuit, plus I'm going to get Metro E from it, and I'm putting up a cellular station?
So it kind of depends on who you go and procure, buy that solution from. So the question is, is it a one-stop shop, or am I actually piecemealing this together as a customer as far as the circuits go? And the answer is there's options. So from a product management standpoint, for the company I work for, we want to procure everything on behalf of the customer. Because a lot of customers, as many of you are aware, we'll take the situation, or what I just described, where I'm racing home and getting on my laptop, right? So let's say I diagnose the problem. Usually the problem is either equipment, circuit, it's usually what it is, or there's power problems at the location, right? And a lot of times, even though there's a couple components there, you get a lot of back and forth, right? So if it is my service provider, a lot of times we'll misdiagnose, whatever, and say, no, you need to check power there. I'm not seeing this, I can't loop the smart jack. Who knows what. they'll give, it's more of a kind of that back and forth, or check your equipment. So some prefer to get it from a one-stop and say, you know, one throat to choke. You know, it's down, you fix it, and they fix it. It really is kind of more so dependent on vendor. There are some where if you're really good and you feel confident with all this and you want to save some money, you can go and deploy it yourself even, go procure the equipment, put it in place. There's a lot of good solutions out there like Silver Peak. Then there's others where it's more so managed, whether you're looking at like Viptela is a pretty good one that Cisco recently acquired, which they have a couple different models where you can have somebody manage it for you, or you can go and buy that and put it in yourself. To me, a lot of value is the aspect of having somebody provision it for you, manage it for you, be responsible from an SLA compliance aspect, and you have visibility and a chance to work on other things. Then again, that's just me trying to sell it, right? So there's options as far as who gets those services.
And I have one more. Is cellular basically, you know, a contingency? I mean, even if you have 4G, and 5G is going to be great.
We're all talking about 5G.
Yeah, right. 5G is going to be gigabit.
Yep.
But until then, is this just, you know, if a truck hits my D-mark, or, you know, the backhoe gets it, I'm still working. I may have, you know, 30 meg, but I'm working.
Yep. So the 4G aspect is good, and I know way too much about 4G than I should. It's one of those things where we got deep with it from our company of how that's all delivered. When you're looking at like a Verizon, from a service standpoint of what you can expect, usually around 20 meg down, 5 meg up is what you can get from an optimal for like a Verizon. 5G is going to be, that's going to turn it all upside down because you are talking truly gigabit type speeds. And 5G is around the corner. You know, I'm going to tell you, we're already getting ready for it, right? We do a lot with these. The company that I work for, we do the fiber to the tower for Verizon, Sprint, T-Mobile. We're the primary vendor for all three of those in the Carolinas. And we're already making preparations of 5G. It's going to be interesting. It's going to change everything, unplugged. But today's world, from that 4G perspective, though, as a failover component primarily, not something that you're going to use necessarily all the time. From our testing voice side, which is critical to most businesses, you can have 30 concurrent voice calls over a 4G session. So pretty good, right? You think most businesses that were like a PRI, 24 concurrent lines, you can kind of accommodate that with 4G during a failover.
So is this bonded? If you have all three, are they bonded?
They are. That's another component too. And I'll show you how that all works too. Where previously what you would normally do is I'd have my MPLS connection, right? It's there, it's connected, it's usually always up until, you know, especially in Charlotte, they're digging up the roads, they're backhoe out in front of the business, landscapers doing this. Usually that cut fiber is what they call like the last mile, which is where it goes from your business back to the telco. Because you're usually single threaded in most entry points. When that gets cut, and that's why you always you hear the radio call before you dig, yada, yada, yada. Because when that fiber is cut, you're looking at a little bit of a downtime before they get out there and splice it all together. You'll hear every telco in the world say 4 hours, but it takes a little bit. Right? So when that happens, though, you lose that primary, we're saying fiber is the scenario, connection. If I have broadband there as a secondary connection, normally what I'm doing is I'm physically going up, plugging that fiber, plugging in the broadband into my router. But usually what happens there is I can get on the internet, I can get to Facebook, YouTube, all that, yippee, right? But I'm usually losing my private IP addresses, which means I'm probably losing Exchange. It depends. You know, some people use Office 3, a lot of people use Office 365. But you're losing like that connectivity to normally your private IP addressing, which is your servers. A lot of times it might be your phone sets. And all you can really do in that scenario is get out on the internet. Same with 4G as a backup. When you use the solution, what it's doing is it's literally bonding these. So they call that WAN optimization. If you wanted to do that, rewind back the clock, you purchase a piece of equipment, usually like backlight, something like that, usually about $30,000 appliance that you put in your network. So this brings down cost dramatically to bond those. And then I can use all three of these at once if I want to become home about it. The normal deployment, we'll show an example, is the cellular is usually in a standby mode where it's waiting for, if your other circuits, you've got like, force majeure, a hurricane going on, knocks down everything, that 4G will kick in automatically and start being used. Otherwise, it's usually just sitting there waiting for disaster. Good questions. Thanks for the input, Dale. With time in mind, I'll go through a couple of these other spots real quick. Kind of reiterating what we were talking about here. A little example, you kind of got your public internet, connectivity back to the gateway from the edge. Then you have your components of your LAN infrastructure, and then your WAN options. So say like 4G, broadband. What's happening there is it's actually pinning up IPsec tunnels. So that's the traditional way of, you're home on your laptop and you connect back or VPN in back to the business. Usually it's a Cisco, a Fortinet, Palo Alto client. You can connect up, and what it's doing is it's hairpinning up a connection with X amount of bandwidth allocated to it to give you connectivity back into the corporate infrastructure. Problem is it's really one dumb pipe. With SD-WAN, you're getting multiple of these IPsec sessions going, and it can prioritize and say, this is my video, I want to give it the highest priority. This is my voice, next time. This is my business data here. And then it gets a little more granular. That's even how MPLS works. It looks usually at 4 queues and says it's going to have this prioritization. SD-WAN goes a little deeper, and then it gets down to that application layer, and it'll say, it recognizes, oh, this is Office 365, I want to put it up here. This is Dropbox, you can have a large prioritization and put it down here. It's pretty cool stuff how it works. And when you have your MPLS component, you connect it back to that corporate gateway, you have access to your own corporate firewall, or if you're using a managed site firewall. And then also you're seeing, as a result, somewhat of SD-WAN's efforts, but an overall kind of thing that SD-WAN falls under is something called SDN, for software-defined networks, which is where we're kind of all headed, which quick access to a lot of these common business applications. But the way of yesterday of connecting up publicly to those services are now moving to a private aspect, right? Where Google Business Apps or Azure are seen as a location or a node on my network, private, as opposed to going over the public, which gives you usually lower latency, less packet loss, and secure connection.
So in this, are you talking both VoIP and data?
VoIP, data. So here what I'm talking about, and again,
Because I'm looking at the lower right-hand corner. Right?
yeah, the lower right-hand corner, public internet, right? So I'm using the public internet as a transport to get into my private network. Usually that firewall is your bottleneck where, and my outbound traffic to the public internet is usually from the firewall. I'm sorry, I actually said that first. Your firewall is usually your entry. When I'm using public internet, going over privately, and then actually get out to the public internet first. You see that now? Traffic flow example is kind of reiterating what we said here. You might have those circuits that are going over an MPLS or private network, and then you also have those that are using internet consumption bandwidth but it's quietly connecting you back into the gateway, into the net. There's a lot of cost savings that you have in here. That's probably one of the big things, especially if that's from your responsibilities where you work. As a service provider, and if you're ever talking to someone like me or someone that works for a Time Warner or a Spectrum now, and all these name changes, the Spectrum, a Level 3, Windstream, they're always going to try to sell you the high cost of the circuit that's fiber based. And there's a lot of validity into having that fiber-based MPLS circuit. But when you start talking about like the remote locations where, hey, I got 5 people there, I don't necessarily need to spend $1,000 a month for network connectivity. They have other options that they may not even make you aware of, inquire about. There's it's been out there for a while, but if you're heard of Ethernet over copper, it's where they actually use the copper lines that are in place, usually legacy AT&T copper lines or whoever the incumbent is in that area. They have these copper lines that what they can do is do emulation over the solution and get you higher bandwidth. So
How's it different from DSL?
it's very simple.
Right?
Yeah, you're modulating the line. It's very similar. It's just you can get higher bandwidth, and it's DSL is usually asymmetrical, and the upload is usually what hurts the most. Ethernet over copper is usually a distance component to it. The only problem with this, well, I should say, there's a couple of problems, but one of the main problems is, if you're 14,000 feet away from the local service office or that telco pop per se, then you're out of range from a modulation standpoint to really get good bandwidth on it. But if you're in that range, you can get like a optimal for Ethernet over copper. There's some new things they've done from a modulation standpoint, but the standard that's out there is you can get 40 meg down, 40 meg up, and you can usually get it, instead of that $1,000, you're looking at $100, $200. It's much cheaper to deliver. 4G LTE, an interesting thing. I know some of y'all work at the banks and all that, but I recall back when we had the Sandy storm that happened, right? So hit New York, Long Island, everything terrible, and a fiasco that happened there. At the time I was doing a fun fundraiser, a chili cook-off down in Columbia, having fun with my pals, and one of my buddies, we're all telco and IT nerds, we're having fun. And he goes, I gotta go. What do you mean you gotta go? We're having fun. He goes, I just got a call because it's Sandy, and he worked for Wells Fargo. They said, they're loading up with some equipment, and I gotta head up to New York. And what they were actually doing is they had vetted and had tested and pre-approved for launch using 3G, 4G as a data connectivity method. But everyone was scared because it's over the air, right? And there, since it's a crucial downstate, they decided at that point to deploy 4G for the bank connectivity of some crucial data in New York. And what was interesting is on my side, I saw the ripple effects. Once the big banks went that way of 3G, 4G, the smaller banks, the community banks, all fell in line. And then the business that we had before of fractional T1s, fiber circuits to ATM, went nothing. And everybody wanted, if you don't believe it, a lot of your ATM machines, the connectivity is 4G. There's something behind that ATM machine. So we're all secure and all that good stuff, but it's going over. Right? That's right. It's going cellular on most of those ATMs. So it is a way to connect. And then cable modems are so prevalent. And you used to be able to shoot all these goals through and say, oh, it's a horrible experience with broadband, right? But everyone's kind of used to having it at home. Yes, the speeds might not always be what they sold you per se.
Mileage may vary.
Whereas, if you buy a fiber circuit, you're probably going to get that speed. Sometimes depending on fiber, it depends on how people in your neighborhood and all that type of thing. But in reality, you're getting usually some pretty good speeds at a low cost. And that can work just fine for a branching point. interesting thing to kind of show here too is you can do a lot down at the application layer. This goes, it's dependent on vendors. I mentioned a couple earlier, I'll show a couple examples in a minute. But most of them have some type of component of this as part of their solution. Kind of a must that they have for SD-WAN is the WAN optimization, so being able to bond those multiple connections that we've already spoke of. But a lot of them are doing this from an application control standpoint. Some have a larger or more extensive library than others. Most you'll see though, the ones that I've seen, they know 99% of your traffic type. The only time they get caught up a little bit is if you've got some homebrew like Citrix-based solution, but it'll still recognize it as Citrix-based. Give kind of a point value to the reporting. What it'll do is that library is going to say, okay, 99% of the users that have Azure, that has a higher priority, and
That's work.
yeah, it's work, right? And it's in play stuff like this down here. So you get assigns it different values, and it's already making some assumptions of how you're going to use that traffic and factors that. And that point value system can get really granular. We'll show kind of how that works in a minute. But what it can do is make assumptions of how you want that traffic to be handled in certain situations. And you can, as an end user, override that and create rules, and it's easy. It's not like, it used to be you want to do anything like you get your command line, you're just totally nerding out trying to figure this stuff out. Now the GUIs for all this stuff are pretty easy to select and make changes to it. But to be honest, out of the box, you leave kind of the default way that it handles it, it's going to do most of what you want to do. And one of the things you might want to do is this, right? So in my previous scenario here, right, I've got broadband fiber, say 4G, MPLS. Let's say I go ahead and I lose broadband and fiber. So in that scenario, I found over 4G. And again, we kind of said there's constraints on how much bandwidth or throughput you can get over 4G. So I probably don't want Netflix cruising along while I'm using 4G, because 4G usually works on a consumption-based model too, where it's how much you've actually consumed from an upload, download standpoint. And it's, most of those packages are set up where they're 1 gig, 2 gig, 5 gig, 10 gig. If you get a streaming 4K Ultra, HD 4K movie on Netflix, you'll take up 30 gigs in an hour, right? It'll burn through bandwidth like that. So I might say, I'm going to kill all this traffic off, only have this business critical, and then I'm going to assign it accordingly of what takes top priority. Now, it doesn't mean, in my rule set, I may want to kill this totally off. Let's say I'm just hammering that 4G. That Dropbox, it doesn't mean that that just gets discarded, right? It's just going to get queued up for delivery behind maybe my more critical unified communications business critical applications. Dropbox doesn't matter if it gets there a few seconds later, as it does with video, right? You don't want video where it's getting all jumpy. Looks like everybody's doing a robot, right?
So you said it makes assumptions, right? So does that, like, anytime you application from the morning, text that,
Text it,
and then like be like.
And so it's got rule sets in there, and I can show an example of a particular vendor that we're using. I can show you how it does it. So it's looking at however big or extensive the library is. Usually it's 2,000 to 3,000 different applications that it's recognizing. And so it has preset rules. And what it's really doing there, we don't want to fire up a CCNA class in here or anything, but you have the packetizing of you have packets, right? And you have the encapsulation aspect of it. So you got your headers and footers. What it's doing is it's looking at and identifying what that traffic is. And it's doing it from a deep, it is using deep packet inspection. In different rooms, it's got kind of a bad name.
Man in the middle.
Yeah, man in the middle. So, yeah, it's looking down at that packet level to see what is this traffic. It's identified by the header that's really advertising what it is. and then it's making an assumption of correlation to what application that is.
Instead of totally blocking that application, can you like extract down the bandwidth?
Yeah, it's crazy control. Whereas like before, you're either paying premium top dollar to try to have some of that stuff done. I worked with a company, it's a partner. Yeah, I don't know. Sandvine was a company that they're doing a lot of that stuff, and some of the stuff comes out of, you look at like Iran, places like that, do a little controlling on the internet. Some of the technologies really probably came out of that world per se, where they're doing it at a huge level. Not even scale to your enterprise. Yeah, you can identify, you can make certain rule sets, or say, I want to allocate X amount of bandwidth to this. Or you may even want to look at it and say, it's being routed to this subnet, so I'm going to give it this kind of priority or IP address. And yeah, you can create a lot of rule sets and get really granular and so on. Cool stuff. All right, what I'll do is I'll go with slides for another 5 minutes before we break, and then we'll get into kind of meat and potatoes of the demo. But all right, we kind of hit most of these. Just a summary of some of the things, benefits of SD-WAN. That's a big, before, if you've ever had to go and configure BGP, I wish you well, because it's a pain in the neck, right? Usually you have to have some pretty heavy duty equipment from a routing standpoint, and you got to know what you're doing, or you break everything, you're the bad guy in the company. Right? So it's utilizing BGP, it's kind of doing the heavy lifting for you from that configuration standpoint. Previously, you got to have somebody that's pretty highly qualified to internally or as an external resource to play around that. I know in Spirit, there's certain people you just don't give access to get there and mess around with the BGP rule sets for routers. Yeah, another thing that I'd be mindful of is, so an MPLS, one thing that you are giving up here, it depends on how you roll out the solution. So if you're rolling out internally, then you don't have to worry about it. If you're letting somebody like a managed service provider or an ISP put this in place for you, they're going to want you to have a layer 3 network, right? Because from a routing standpoint, they have to have visibility into the network to make changes. So I can't just go have like a community bank go, hey, we want SD-WAN. And then I say, yeah. All right, we're taking over routing for you. They usually don't want to give that up, right, from a security.
They like layers.
They like layers. And I don't like them. I've already been involved in a couple of deployments where, oops, our salespeople sold this, now I got to figure it out. But really, when we have had to deploy it that way, I was relying on the customer to tell me their IP addressing scheme, and I would have to mimic that in the box I was putting in place. It's not right. So if you have a layer 2 type network design, and you want something like this, you're probably going to go get your own equipment and put it in place. But it's a bit of a tall order to do on your own. So what is really cool, and it's best I show you an example of this, is I can choose for certain traffic which circuits I want to utilize. And if it sees a failure, it can trigger and then reroute over the better performing circuit seamlessly without having to actually do anything. They call that DMPO. I probably should have brought up the acronym. Dynamic multi-path optimization. One thing to be mindful of SD-WAN, and I almost got in a little bit of an argument with somebody recently over this at a SD-WAN panel, was they were trying to say that there wasn't any overhead with our SD-WAN solution, and inherently there's a lot of overhead. Now, if you don't live in the networking world, which overhead, what that is it's the extra fluff, right? It's the extra stuff that's needed in order to get from point A to point B. So usually, think of like mail delivery, right? You have an envelope with an address on it. let's say I put it in a box, a UPS box with another address on it, right? To get from point A to point B, I look at the address, okay, it goes here, I open it up, then I see where it's going to go next, and I will hand deliver it to whatever address is specified there. So, traffic routing, where we're going with that? Overhead, yeah, goodness gracious. It went over my head for a minute, I mean, overhead.
Multi-pan has it.
So, overhead standpoint, what that'll do is every time that you kind of address, right, packetize, you're putting another layer of overhead. Like for this instance, 59 bytes. Doesn't sound like much, but when you're looking at it per packet, that becomes quite a bit dynamic, right? So I'll argue all day with somebody. There's a ton of dang overhead that goes with this. Because you have that per packet overhead, creating busy traffic per se. And then another thing, because everybody wants to see it with this, is there's a whole lot of analytics going on. So you have, there's traffic there that's being generated just for my analytics standpoint of rolling out SD-WAN. From what I've seen in talking to our vendor, and well as other vendors that we've vetted, you could see somewhere between 10 to 25% overhead. It's significant. But when I really push those vendors out, they're like, yeah, but you get so much more bandwidth because you can put all these other, links in your pocket. Another thing that's interesting for those that have like MPLS in place today, when you're looking to have this live alongside it, most SD-WAN deployments that I've been involved with, or actually all of them, have an MPLS component, so that's kind of a big thing for me. But the way that MPLS does traffic control and routing is something called a DSIP value, which is the outer packet tells me that this is voice, this is video, this is business critical, this is best practice, right? And routes it accordingly. If you are considering SD-WAN, one thing you want to be mindful of, some vendors handle this the right way and other ones don't. And what I mean is, some will say, okay, this is marked as such and such. I'm just going to honor it, go, right, route. A lot of them, though, don't really discern that too much, and what they'll do is they'll packetize it anyways. So they're adding additional overhead where it's not needed, right? Because if you have native MPLS, your security is already kind of taken care of with what's happening there. It is encrypted, it is encapsulated. Why do you need to re-encrypt it again, right? It's a little inefficient. So, if you are considering vetting vendors, ask that question. We'll get into that with the demo. Yeah, better off to show you that. But the compliancy measurements, there's so many out there. So, and believe me, as a vendor, it's to their advantage to try to be compliant with all these. So most of them are. But you probably, if you work in if you're in healthcare, you obviously want to make sure you got your HIPAA boxes checked. Which is interesting though. When you really tear that down from a HIPAA, I always get asked HIPAA questions. But HIPAA is usually more about where that data is stored, not in flight, right? But they'll ask, and you probably want to have your boxes checked for that. You've got Pci Compliance if you're doing some sales transactions, Sarbanes-Oxley if you're doing some financial, and then, if whatever field you're in right now isn't covered up with all these compliance measurements, don't worry. I'm sure they'll create it. They'll catch up with you soon. So they're all out there. We'll show this as an example, but what's really kind of cool is some of the virtual aspects that you can do with this as compared to having physical hardware. We'll talk to that example more, so focusing on the slide. One thing that's probably worth talking about before we even demo. It thinks of throughput differently when you're looking at SD-WAN than your traditional ways of thinking of throughput. When I think of throughput, I think of, if you tell me you have a 10 meg circuit, I say you got 10 meg up and 10 meg down in the bandwidth. When you're talking SD-WAN, they say, oh no, that's a 20 meg circuit. Okay. So what they do there is, since they're putting in consideration asymmetrical circuits and symmetrical circuits, they look at total throughput since you are bringing all those circuits together. So you really want to keep that in mind if you're vetting a solution, because they may sell you a 50 meg solution.
You'll get 25 up.
You're getting 25 up or 25. Now the interesting thing is though, is that you could out of that 50 meg solution have 40 meg down, 10 meg up, it's whatever what your total consumption would be. So just be kind of mindful of that if you're looking right now or have something. Yeah. All right, so common vendors, just want to touch on a couple real quick. Well Cloud, which is one I'll be kind of showing an example of. Viptela is a really cool solution. They were recently acquired by, and all these ones are being acquired. If you had a good solution out there, the big boys came and grabbed it up. So Vela Cloud got grabbed up by VMware the last 2 months. Viptela, I think about 4 months ago, Cisco went and bought them. Cisco's funny. They got 2 solutions for everything, it seems like. So they have Viptela doing SD-WAN, but then, or you could buy this kind of like over here, you can get the Meraki as an SD-WAN solution as well. So they position it a little bit differently, but they're both good solutions. They're pretty versatile with the CDP selection as well. Scale and how big you want it.
So, I'm sorry. So
Good.
On these appliances, the software is on the router.
No, in actuality, the weird thing is, it's a little different way of thinking. Traditionally, your router, your software is there, right? The way that it works in SD-WAN is really the computing, the heavy lifting is being done at that orchestrator. This is really this router, right? It's looking at the traffic, it's handling it accordingly.
Yeah.
It is aware of rule sets, but
So it's not.
the real compute, heavy compute side is the orchestrator, not now.
So it's not a.
It's a router.
About this router. It's just a router.
It's a router.
Okay.
But, I'm going over a little bit. You mind me talk for a few more minutes? Y'all want a break? You're good? Keep right? Okay. So what's really kind of cool that's happening in the telco space, and it's really per the direction of data centers and the way that those environments work, it's moved its way to the edge, is the traditional way they think of a router, a switch, a firewall, a media converter. That's all kind of going out the window. And what they're all doing now is you have your bare metal appliance. So it's kind of one of those things where it's like, gosh, why is it taking this long? It becomes whatever you want it to be. That's what's going to happen here soon. It's already happening right now. So what it is you'll have a virtual spin up of a router, of a switch, of a firewall, vendor choice, and it'll go beyond that box. It's interesting. It's cool how it's kind of caught up, because that was bread and butter for a lot of those providers for a long time, was selling you that piece of equipment. Oh, you can't get this anywhere else. This is great. You can use our fiber SFPs because other ones won't work. So that's all out the window, right? It's more so a thing of, I got my chassis, I want a virtual spin up. The way that telecommunication, they're calling that NFV. And they're saying it's BNF, you spin up on a virtual network functionality. But that's kind of taking place. And the boxes that they've got soon to release and some that are out there are really cool. I mean, there's always been that modular aspect where I screw this, I pop this out, I put T1s in here, I put 10 gig instead of gig, where they get really modular. With the 4G integration, ports, whether they're gigabit copper Ethernet or different SFP or fiber modules, it's pretty wild. And, that's coming in here. Viptela really does a pretty good job of kind of tying it into software as a solution providers, and put in considerations and requirements that you may have existing on the cloud. That's probably a leg I think of their But what's even happening now too is you have these vendors are getting deals with AWS or Azure where they're saying, let me have a virtual instance of my solution in your cloud environment so that it looks like it's an edge device for that environment, your cloud-based storage or cloud. Silver Peak, they've kind of been in the game for a while now. They've got a really solid solution. The hardware they got here is something they team up with a company called Telco Systems. But good stuff, and probably the preferred way of a lot of enterprises that are doing it themselves are using Silver Peak. Yeah, we don't need to talk about that now. I think we're good to break right now, and what, 10 minutes? Does that work? Kind of have some conversation about this, but I figure this is a slide that's just worth showing. I blazed through a couple of the other slides I had, but if you are considering, these might be some of the vendors to look at. If you wanted to go home and do it your own, you can work with a lot of the premium providers out there, like Viptela, CloudGenix, VeloCloud, Versa Networks, Cyvera, Larry. I don't have Silver Peak up there, because they're on the other side over here. But if you're really looking just truly, I want to optimize my WAN connections, you can actually, from a license perspective, just get that through like Cisco, Riverbed, Juniper, Citrix, Silver Peak, Alcatel-Lucent, which is now Nokia. or work with, I have CSP, that's kind of a newer acronym, Cloud Service Provider, that's what that is. Verizon, BT or British Telecom, Telstra. Really, most of the telco providers out there have a solution in place at this point. And then you can get it as a service too directly from some of these vendors. But question being was, cost and how that all works. Some of them are expensive, some are a little cheaper. The funny thing is whether you like it or not, just the way all this stuff evolves is you're probably going to get it almost included a couple of years from now. Because we're already starting to see that, like the vendors that are coming out with their next generation of core routers and all that. Like right now, we've been looking at, we do a lot with Alcatel-Lucent, which is now Nokia. Their next generation, they have something called Deerfield with WAN, which has a lot of software components with it. So it's one of those things where it's going to be somewhat included in a lot of the next generation stuff. A little fuzzy here, I did a little copy paste, but whatever, it's good info. I wanted to grab it. So just think of, from a survey standpoint, you are getting a lot of traction of people that have taken on SD-WAN or plan to in the near future. I should probably replicate this and create a little table. But I saw this the other night. I said, yeah, okay. Where you're actually, there is a lot of money being exchanged over some of this SD-WAN that has spurred interest, spurred its growth. Whenever you have money in something, it spurs some kind of activity with it. So with the migration and adaption of SD-WAN, it's improved. All right, some of the main components that we've talked about. And I'm going to go ahead and get into some foot demos. So if you're, again, a shameless plug, I'm not trying to do that, it's just what I've got. Oh gosh, I lost it.
Guys,
Oh, I grabbed the darn internal. I don't have that password at all. Do that again.
Or certificate.
Sorry. Sorry, well, I connected to the guest network. I thought I connected a million times with this darn laptop. I tell you what.
Try MSD and Microsoft.gov.
There. Cool. How many times I told people this code? Yeah, geez. All right.
Supposed to be lowercase.
Same every week.
Wrong.
Lowercase.
Ah.
Lowercase, and you're using the network instead of the code.
I screwed up.
It's MS event, lowercase. And 95 SW.
Don't make me so nervous.
You're we're a tough crowd.
Is it the same every week?
Yes.
All right. Ta-da. Okay. I'm gonna actually show you. I'm gonna show you our own dirty laundry. So I'm gonna look at actually Spirit Communications corporate network. So it's why not? It's one. And this is one of the problems with SD-WAN too, right? You can show everybody all your data.
I go.
What you're seeing here is I'm logged in. It's telling me where my locations are. So a nice clean map. Again, any of the SD-WAN kind of solutions you're looking at are going to give you something like this. And then where you see a 2 there, where Charlotte is, if I drill down that, it's going to show a warehouse in Rock Hill and then an office that's just up the road here. Green, obviously, the networking world means good. So stating that all of these are up. If, for instance, this Columbia location were to go down and see it go red.
Back in the car.
Yeah, I mean, the car did, right? But some smaller, medium-sized companies might even use this as like a wallboard screen to see how things are acting on the network. I don't think of it as like a replacement per se, or if you've got solar winds in a knock environment or something like that. But for a smaller, medium-sized company, it'll give you kind of, hey, this is what's going on, right? Status green, links, you're kind of seeing numbers associated here. What that's referencing is how many actual different circuits or WAN connections I have at those different locations. This Augusta remote office, you see this one in gray because, as we talked about earlier, like the 4G LTE, there's a 4G connection there, and it's in a standby mode, so it's not necessarily in an active state right now where data is transmitted over. Because we were talking earlier about overhead, even though I'm not transmitting any data, or if I wasn't really transmitting any data, but I kept this link alive, the busy traffic associated with SD-WAN and analytics generates 2 gigs worth of traffic in the log as well. You kind of notice when we lap it up. So again, I hear somebody say no overhead, I call a little BS action there. And then you have these different links here and some pertinent information on the firmware build. If I hover over like this Charlotte sales office, we pick on these folks, you see, it'll give me some data about the actual connections. It is pretty smart. Like, I didn't actually even go in and tell it what kind of circuit it was. It realizes it's doing a lookup to see who is the related provider as well associated with it. Now I did, we went and actually had a Charlotte private, I'll show you in a second what we did actually get it here. Cloud status, was talking about that for VPN status. it's talking about those connections that we talked about earlier to the orchestrator and then to the gateway. Saying those are out. We're going to pick on them. So we'll look at the Charlotte sales office for a second. What's interesting to see here is throughput right now is showing 0. Just keep watching it. In a few seconds, it's going to change. But bandwidth, it actually takes a historical kind of snapshot and realizes what circuit sizes are delivered there. So it knows that, hey, this from what we've gathered from previous historical information, this is really a 50 meg circuit, a symmetric circuit up and down. And this is a fiber circuit. In this instance, it's a spectrum provided one, in which is it's actually a 20 meg circuit that we're paid for, but 10 meg up and 20 meg down. And then you're seeing real-time throughput, or near real-time throughput. Right now, that office is closed, so I'm not going to see much data there. What this is really is probably some busy traffic that's RTP associated with, well, IP phones and things like that they've got in the office. It's interesting here, too, is where it has this signal over to the right. If I click on this, it expands out and it's going to tell me kind of the goodies and what you care about from a model score or from a quality of service standpoint that make up a model score, which is latency, components, jitter, and packet loss. There's certain thresholds there that when you hit them, you're going to have a rough ride when it comes to video or voice service. It's looking here over the past 12 hours from this dashboard standpoint. I can change that. And it goes back a significant amount, right? I can go back to the past year, look at information, which is cool. And it's a lot cooler when I show you something here in just a second. If I scroll down here, you'll see like, it's just showing me a quick snapshot of top applications out of that particular office. And of course it's a sales office, right? You got Facebook and YouTube making a lot of strides there in the last 12 hours. That's good. Glad they're doing well there. It'll tell me the operating system and what's connected to that network in the last 12 hours. It's also going to tell me source of traffic by device type. And then some of this application, how it has it categorized, and what's making up that traffic type. Now, some of the special sauce, I'll just, for kicks, I'm going to click over the last, 30 days. All right. Just come back and say, all right, last 30 days. Again, sales office, blooming on that. YouTube is
More than your SMB traffic.
good thing they're making a quota over there. Yeah, their volume of traffic, the biggest dollar of it is YouTube. And to be honest, whenever they get customer networks, I always talk, not in my head when I'm meeting with an IT guy or security guy, they go, well, we protect our data, and we make sure none of that nonsense happens, and okay, every time I look, it's YouTube, Netflix, top of the list. There's so much you can do, right? But that's a good thing too, is you kind of get some visibility. If we wanted to meet to these folks, we could throttle them down on our firewall lines or this stuff, right? But so you got your top applications. It's just kind of expanded out the past 30 days. If I want to get a little bit more granular with that, click here, or I can go in this application. This is pretty cool what it does here. And so it's trending it out over the last 30 days. You can tell when your business days are as compared to probably what the weekends are. And you have your peaks and valleys. And then again your applications. And I can graphically cover pretty on again, uncheck and check to show certain things here. But where this becomes really kind of a useful tool is you have a location, you got a trouble, you're wondering, well, what the heck's going on at this office at this time? What's making up the consumption? Why am I having a problem with transmission of this and that? Before something like this, you had extra work that was probably done by the service provider, and you had extra work that was done by the customer to diagnose certain things. Go back to the example where, hey, what's the deal here? Are you just trying to sell me more stuff, or or what, because 3 years ago I had bonded T's, last year I had 5 meg, now I just bought 10 meg, you're telling me I need more, what's going on with my traffic? Normally, if you called your service provider and said that, they'll send you maybe a little graph and say, yeah, look, you're using that much traffic, that's about it, right? If you're nice guys, like we sometimes were, we'd say, well, let's help you figure out what's going on, and we'd do some certain tests, but you'd have to be proactive with that, right? We'd say, all right, let's do an ethereal capture and look at the traffic components of it, or let's do something called like iPerf. It's really complicated.
Proxy server.
Yeah, there you go. Yeah. Or you can go the traditional route with a proxy server. But a lot of times what we find ourselves doing, and I'm not saying it's the best way to operate, is, we don't want this customer solid with us, so we do a truck roll. So we'd send out a technician, they would plug in at the main switch or distribution switch there, and then say, okay, I see the traffic generated from this switch over in this closet. And they take the laptop, plug in there, and look at it, and then go, okay, it's coming from here. And then come to find out, oh, I'm eating up all this bandwidth because Andy in accounting's got BitTorrent running with Netflix and he's streaming all this stuff. And so, there's my problem. But usually have a lot of frustration by the customer. The service provider, we spend money on a truck roll, it's expensive, and then the time of a technician to kind of diagnose something that's really past the DMARC, traditional responsibility point. With this, I can kind of go and really quickly figure out what's happening with that traffic, what's taking place. So the last 30 days, there was a little peak there. So if I wanted to see what it was, I could do a hover over, or I could just do like a drill down. So I click and hover over, it's going to drill down for me. And again, what I'm showing you here is Bella Cloud, but they all kind of work like this. And you can see one of those peaks was, you wouldn't believe how many trouble out of that for Windows Update causes. But Windows Update can be a bit of a bandwidth consumption hog.
And look what's on pays.
Yeah. Come on, let's have some consideration here. Business hours, people. It's really funny when you kind of get at the heart of some of this traffic and trends of it too. And I mentioned earlier, like looking at bandwidth and consumption. So caused us a hell of an issue was when Windows 10 rolled out, and the way that Microsoft rolled out Windows 10, right? Hey everybody, it's free, download it.
Yeah.
Great, and then, this is your last thing. There's certain timelines that they outline that had adverse reflects on those networks, right? Because you had mass amount of bandwidth. And it's okay when you're at home doing it, right? But if you're at your business doing it, and 100 of your buddies in the office are doing it at the same time, you get a little bit of bandwidth consumption there. And the way that they did it was a little bit different than they've done in the past, too. It actually is kind of cool, because remember, we had, through the group, we had Stephen Rose, who was the product manager of Windows 10 deployment. We got to be a part of that. They kind of had that whole roadshow thing, and we met over here, and we were talking about it. And I had a little side conversation. I said, man, I'm a little worried about y'all rolling this out. I'm like, how are you deploying it? And we were talking through it then. No big deal. We're going to do it middle of the night. We've got different partners. Well, what they did is, when you look at like Apple and how they, I definitely don't like to always praise Apple for sure, right? Whatever. I don't really have a dog in that fight. But is you can two different deployment methodologies, right? The service providers have these different agreements with what they call like caching servers. And a common deployment is a lot of the websites that you go to, whether it's CNN.com or whatever, it's usually hitting, you'll see, like if you really look at it, I'll show you something. It's right here, CDN, cache delivery network or content delivery network. What's happening is there's servers in the service provider's network to get that traffic closer to you as the consumer. And usually as a service provider, we say, okay, we'll provide the power, we'll provide the server space, give us those servers, we'll plug them in the network. And the reason the service providers want them in their network is you get a better experience out of it because you're closer to the data that you're pulling. And Well, no,
They don't.
some do. I imagine AT&T's probably getting paid, a little scared of communications that get paid. I know I used to get called to replace fans in their servers all the time, and like, so we actually, the service provider actually takes on maintenance aspects of those servers too. It's really well. But no, was that service providers usually pay for internet bandwidth, the way that we connect with each other, and that's free, right? So I can bring it, if I bring that on net to my network and then distribute it to you, it's a more efficient way of delivering too. Because if I go and put a file on a server and you go and try to access that file, whether it's going to be like CNN video or who knows, this is something that's accessed frequently. I put that data here, and I don't have all these streams of data across my network trying to get back to Seattle, Washington. Right? I'm getting a CDN or one of these on-the-fly delivery aspects. I've gone on top of it. What they would do a lot of times for these updates is you put it on caching servers and you split it up. Microsoft took a different approach. You went to a source and you download that whole darn thing. They've changed that since then and have all these different pockets where it'll put together, your request and send it to you, but we had a whole lot of consumption going to just particular servers on our network calling from the village. But it happens. But again, if you look at this traffic type, right, it's kind of interesting. It doesn't matter which networks you look at. You usually see a very similar thing to what I'm showing here. You see in Microsoft, right? You'll see SSL. So that's consider that part of the overhead aspect. That's the VPN, the secure aspect of the tunneling that's taking place to make this happen. YouTube, goodness gracious, I don't know if you do. RTP, so that's what's kind of used as the communication for voice services. Yeah, I don't know what Google generic is, but that's probably like something. But actually, I'm still zoomed in. Let me go back out. I'm on that snapshot of time looking at that update. Let me go back and show you the larger scale of it. Let's go back far. This is what really impressed me about this stuff. Let's look at the last 6 months. Now, if I ever tried doing this, like, I'm sure all of you have different syslog servers or historical information you retain. Usually it's a nightmare where a customer says, hey, I'd like to see a report for last year. I'm like, dear God, don't ask me to do that, because grab a Snickers bar, I'm waiting forever for that data to ever actually populate. They use some pretty cool algorithms to make this stuff happen damn fast. You think of all that's pulling. So this last 6 months worth of traffic, if I scroll down, I can say, YouTube is top of the list, thank goodness. But same type of trends, right? You got your Facebook, you have RTP, HTTP, but it's also showing 429 other applications that were accessed in that time period. That little double arrow, it's going to put them all in order based on consumption. So whether it's iTunes, Dropbox, App Store, Instagram, Jabber, but it's looking at consumption as a whole for the past 6 months, all the way down to the bytes level, which is just crazy to me, because it's a lot of visibility into that. Well, what I can also do is I could go and say, hey, what's the source of all this traffic? What is it? So now I'm looking at it from a source standpoint. You scroll down, it natively, it's going to do some magic with SNMP and DNS to source all of the objects on the network and consumption. And now this is, I think, smart people may in the room with this, but I believe this is Windows default naming convention that we're actually using for our laptops. And the IPs that were allocated to them when consuming the majority of this bandwidth, MAC address associated, how much consumed, and it's doing on a top-down approach, which can be good for troubleshooting. We also have customers that like it for an HR perspective. You want to say,
Well, where do we track back to a username? Does it resolve that too?
you can have it resolved back to, so it's dependent on the solution type, dependent on the deployment. and whether or not you're doing LDAP integration or not. So for this, what you'll see is we're actually doing back association and it's the naming convention here. So I'm not doing LDAP, but most of your providers do allow for an LDAP. Invited that. If I scroll down here, though, I can kind of also see.
Look at his iPhone.
Hey, Bill's iPhone. Morning. All right, everybody's on stage. And when you see this green dot next to it, it's telling you that this is currently online. Right? So currently online. It's not on there. If I were to do a hover over or a drop down here, you'll see currently offline last time that it saw it on the network. And associated MAC address, West County. I'll pick a card because he's my good buddy. If I click down on his and look at what he's done, this beamloma.net is actually bad. It's shame on Spirit for not updating DNS, but it's an internal resource for us. This is basically what you got now. Now looking at kind of someone's laptop here, and again, top applications, top destinations. Looking by domain, FQDN, or by IP. Interesting stuff. Give you some good
application
feedback.
per user.
What was that?
Can you limit the applications per user?
So it kind of depends on the solutions that you so the way that we've deployed it is we don't, there's, a lot of these have a firewall built into them. So you can use that. However, you know, they're an SD-WAN company, not a firewall.
Right.
So I chose a firewall with like Fortinet, Palo Alto, Cisco. It just depends on kind of, you know, where you stand with that. The interesting thing, however, is there are a lot of these ones that they're associating themselves with some of the leaders in firewall. So when we talked earlier about NFV for virtual overlays, they're actually going to have a tab for this particular vendor where you get Palo Alto, it'll show the integration of that. You can do a virtual instance of it on the actual hardware itself. Or you could use the vendors. Our pitch is it's going back to a hosted firewall or a client different rule sets. This is an example of one of those boxes. Somebody, of course, smushed the demo boxes, but if you're just curious kind of what some of these look like, this is, again, it's pick your vendor, but some of them have rack mount options. That's like a smaller office type of thing.
So this is the edge.
That's the edge device. That's correct. Now, here I went back to this transport tab here, and it'll show me how bandwidth is being consumed over each one of those circuits over the defined timeline. And you can see there's heavy preference to this primary circuit as opposed to the secondary. The reason for that will show in a minute. One is a better performing circuit. And some of the traffic is saying only use the better performing circuit for the rule sets that come in place. I want to show you some cool magic here. And this is probably what I like the most about SD-WAN. Because I'm a bit of a voice nerd. That's what I really get into is like the voice aspects of telecommunications, of communications.
So I know what QoS is. What is
Yep.
QoE?
That's a marketing BS. So it's quality of Ethernet, but it's not really an industrial term. What really is, earlier we talked about dynamic multipath optimization. That's really what's driving this. And we'll show what it's doing here in just a second. All right. So last 30 days, it's looking at how both these circuits have performed. And it's using, of course, another marketing spin. Global Cloud Quality Score. Now, it's really a MOS score is what that is. It's the equivalent of a MOS score. So, latency, jitter, and packet loss are those components. Y'all kind of know what latency, packet loss, and jitter loss. Latency is how long it takes the packet to get from point A to point B. Packet loss is, I send 20 packets and I drop 2 or 3, how does it react? Usually not good. So I lose packets. And then jitter is, jitter and latency are kind of very, very similar, but it's tied back to round trip. Here we're looking at traffic type of voice. Some of the different solutions can get really granular by application type. Here what I'm showing you shows voice, video, and like business transactional. You see kind of a little time slot here where it went yellow. And if I did a little hover over, you can see what actually happened there. So it's saying, ooh, my packet loss hit a threshold of 0.7% packet loss. Okay. That's probably not a huge deal, but it is indicating that that threshold was met. If I go a little further back in time, you'll see where some real episodes happened. Back in the past 6 months. Bad example, sir. All right, let's go back here. Didn't help me out much either. What's interesting at how this all works, it actually has historical knowledge and remembers that back in August, we actually had a broadband connection there that was then replaced by a fiber circuit. So it didn't even show this up here. Now it has some historical knowledge of that. It's brought to light. But how that was performing again. I'll show you one that I know is working bad. We'll go to a different office here. So I'm going to go back to one map we were looking at. There's a lot there. All right, so, yeah, there's a lot of course, we've got tech people out there that are always playing around. So some of these other connections you're seeing here, some things they're doing, but you see where it went red here. What would actually, the way that this all, that it would work is, let's say at that moment in time, it preferred this circuit over this circuit. When it starts seeing one of those thresholds being met of jitter, latency, or packet loss, what it will then do is make a decision to use the other circuit as a primary. But another thing that will happen is, let's say a full circuit down state happens and it goes offline. I could be on a phone call, I've got my phone set up, and that circuit that I'm actually transmitting data over cut offline, and it'll keep the RTP session up, just fell over to the other circuit instead, which is really cool. Before, and like usually best case scenario of your other stuff, you're losing dial tone, right? It's not gonna transition like that. That was magic on that stuff. It's really cool. And that's kind of one of the empowerments of what we're doing, especially, depending on everybody's business or everybody's bandwidth is critical. But there's some where it's just absolutely critical, right? Charlotte is definitely one of those towns too. When you think of all financial big decisions that are being made around here. We're talking lots of money being exchanged over telecommunications lines, and to keep it up is amazing. You had a balance statement like that.
So why do you have 2 entries for the same IP address?
Yeah. The only thing I think of here is, and this circuit never went live. I really think this was somebody on our end playing with that, because they created another Spirit or PLS here for this connection that never actually utilized either. I don't know. You shouldn't have 2 concurrent at the same time at the same time. Looks like that one went live. And then somebody was playing a little bit. One of the things to show you here too that's pretty slick is There's alerting components. We were talking before about the aspect of being like on call and something goes down, and then what do? What it'll do too is, let's say you have a link that's down. Yes, it's cool that it's failing over automatically, but I probably still want to take action on my circuit being down, right? Even though, yeah, I want to know that one circuit's down, I want to do something about it. You can have it do triggers where certain thresholds are met, like it's down for 1 minute, text out, email out. And again, that's not privy to one vendor, but pretty much all of them do that. You can give different admin credentials as well. Like I don't necessarily want the receptionist to see what the CEO is looking at from a traffic type, but I might want to give visibility of other aspects of up, down. So I can give a login and give them access to some of those tools, some of that, but not down to the individual level. Then I have my super users that I might want to have to actually say how that traffic is being handled. Use Office 365 as essentially what it's on, move it up the list from how it's handled standpoint. Let me show you something here. So, those thresholds I was talking about, right? You have multiple users in there. And when I get one of those notifications, comes in as a text, instead of having to maybe necessarily run home to resolve it, I can remote into it, which there's a lot of different ways to do that today. If I were to rewind the clock 10 years ago, really, really hard. Usually it was definitely going back home. But here you can do that remote login, right? And then I can actually see what's going on and go, got this circuit down, or maybe I need to call someone to talk to or whoever. Or if I just want to check a few things from an analytic standpoint, I can do it more smart.
Your super user, Kevin B, is that Kevin York or what?
This guy, I can tell you a million stories about him. Actually, I wish he'd come and present to me someday. He actually, he's one of my best buddies, but he's close to retirement. He owned his own service provider that he sold to our company. And I think he made a pretty big buck because he sold the domain of, he owned Augusta.com and Augusta.net. So he did all right when he got out of the service provider business. He came out as one of our senior engineers. But, interesting guy. Used to be a nuclear technician before he decided the internet was a cool thing. So. Okay, one other thing just to show you what we're kind of done at what I imagine, unless you have some additional questions, is another thing that's interesting is, again, you have a remote office, you're wanting to do some remote diagnostics, you have that receptionist there, he or she may not be comfortable getting the command line and doing trace routes for you, or iPerf or JPerf sessions, but if you want to find out some of these things, you can do it from a remote aspect without having to get in the car or to try to talk somebody through that. So what it's really doing here is it's actually, we said this lives at the orchestrator level, but what it's doing here is it's SSHing into the box, and it's going to give me some different GUI-driven diagnostic and tools here to do certain things. Here are DNS tests. So I could put, I did this example 2 days ago, and it didn't resolve properly, which was kind of pretty embarrassing. I don't know why it didn't work.
Let's do Google.
That's what I did. It didn't resolve, but I'm like, let's try and see if we got that resolved though. Google.com will run it. And I'm like, maybe it's a firewall? I don't know what the heck was going on there. We'll see if that works this time for us. It'll take a minute. Yeah, okay, so it resolved here. All right. So let's say the key.217.10.6. I could flush out flows. caddings, list active flows, so if I want to actually, this will probably take a minute. But, depending on how deep you're trying to get in it. You see this right, so I can go, all right, my source destination by protocol source port. Link policy, which is interesting, right? So this is saying, the way that it's set up for that is actually load balancing between my lanes. A thing that some customers have said is, lanes and banks, banks probably banks. They might say, I only want this traffic type going over the MPLS fiber connection, and when it dies, I want my traffic gone that is related to this application. I might not want to have it fail over to the or other secondary, like a layer 2 Ethernet connector. They want it to just use a certain connection. You have to say that. There's certain reasons why someone might want to do that. But you can do that and say only use this But that's a pretty hefty task that I'll put that pretty quick. And then I can also look and see what my this has actually come up helpful for us a couple of times. I had somebody say, I keep connecting and dropping from the Wi-Fi. What the hell is going on with the Wi-Fi here, blah, 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 blah. And then you kind of find out, you go look and go, you know what, you don't really see it connected to the Wi-Fi. Hey, you look from here at the connectivity aspect and don't see her as a client connection, and find out she never had, almost like me here earlier, she was connecting up to the coffee Wi-Fi and then to the corporate Wi-Fi. Okay, so that's part of our issue. You can do ping test, which is kind of cool that you can do ping test by VLAN, because if you're using something like a voice service, you probably use a particular VLAN there. You want to see, hey, can I communicate back to the session port control port? Yes, I can. You see this, I go, well, what is that all about? Reset USB mode. So I was handing around the device there. If you look at it, it's got USB ports. Some of it's kind of hokey to me. Like, okay. Like, the vendor's going, you could set up your own, storage array. And I'm like, okay. Hang it off this with a USB hard drive. I guess you can do that. It's like, all right. But another thing that is kind of neat that it'll do, though, is like, you think of like the MiFi 4G type of connectivity, such as most people have, like, something like one of these jobbies. You can plug it into the USB, mostly it's USB driven, and it can use it as an alternative WAN. And you can almost do it like, let's say I have an oh crap moment, right, where both my broadband and my fiber goes down. I can plug it in, it'll natively see it as an option for the WAN. But it'll also, if I have that paired up through USB, it can run some SMP write commands to where I can say reboot this thing, and it'll do that. Pretty cool. If you're wanting to get nerdy or use it, we don't use it for the Wi-Fi components, but some of them do. You can also look for rogue Wi-Fi. Pretty helpful tools. Trace route's always kind of a needed thing, and it's kind of an overview of demo. Any additional questions? I know we're against the clock.
My friend sent me a YouTube video that I didn't entirely watch, but I watched it. And the premise was they had two cell phones without SIM cards, one in airplane mode, one in normal mode, and they went around the city, stopped at various places, walked around, drove around, and stuff like that. And came back, and they captured all the data that Google had captured on them. And so Google pretty much has dead on where they stopped, where they walked, things like that.
That's why you shouldn't have an Android phone.
Then, the phone in airplane mode actually caught more data.
Really?
Yeah.
That's pretty wild. I mean, we all
Well, my question was, whose network were they using? No SIM card,
I don't know. I
Or
don't
was
know.
it just captured on the phone itself and never?
Well, it's probably captured. Okay, so it could have been through the Wi-Fi, right? That's probably.
Not an airplane.
Huh?
Not an airplane.
Not an airplane mode, but yeah, if you don't have a SIM card, you can't talk back and sell email.
I'll
So
send
I
you
can
the
say,
video.
if creepy, naughty things are happening, I would think it'd be on the Wi-Fi portion.
Can't you do dial 911 without a SIM card? You still have to have a SIM card.
I think you can dial 911, especially on old bricks, you could.
So if you can dial 911, there is some connectivity back.
That is interesting. Yeah, I'd be lying if I give you something I can't. That is interesting. But there's a lot of strange things from a consumption aspect and then the analytics portion. I mean, I work for a good guy. Most of the big ones, I mean, they are truly like, they had that legislation that passed from a service provider perspective. Then I can freely turn around and sell your information everywhere you're searching. Even though you're a customer of mine. I mean, like how slap in the faces and all that stuff.
But like Google knowing that we walked, for 15 seconds when we stopped,
Well, I saw one of the.
What are they doing with all
Is that
the
tape
data?
still on? I saw one of the strangest demonstrations ever. I don't even know what I was watching. It was a demonstration. I won't say the name of the company because whatever, but they're based out of Charleston, and they do some stuff for Homeland Security. And it was a wacky demonstration. I don't know why I was seeing it, but we were talking about more like a mapping tool to like locate our trucks and things like that. Not like anything too sophisticated. However, they're tied into a group called South Carolina Research Firm. There's certain money that goes into it. Yada. They were showing like, oh look, Homeland Security, and they're getting ready for the Cooper River Bridge run, and they were just showing how they had this map. They were literally freehand drawing circle shapes around certain areas, and then they could do overlays and say, we want to see tweets in this area in the last hour. And it would give a summation of all of it. And then they would also, what was really strange is, show me how many 911 calls in this area of this square in the last 24 hours. It would identify where they were on the map. And then show me fire response here. Show me police response. And then, let's just put a layer on there of camera access that are both public, ones that are government related, as well as hotel ones that are just open out there. I mean, it's just crazy how you can pull it like that. I don't know.
The Charlotte paper had over in China that this one guy went to a concert and he was on Lamb and they caught him. The concert had 60,000 people and they caught him through facial recognition.
Well, so I've seen demonstrations. Another thing too that I was working on, there was a whole hubbub of Robert Hughes that built a lot of really cool things in Greenville and really tackled green hit and all that. And Columbia is kind of got a dinosaur way of thinking. But it's like, we're going to bring that kind of cool aspect of Greenville to Columbia. They're taking the old mental health facility there, large campus, and they're redoing it and doing some cool things. Before we did a ballpark there, but they have all these wild plans and aspirations for it. And it's an ongoing project, but we had like Cisco come in and all these different vendors, and it is wild what they're doing with the cameras with the facial recognition. I mean, they actually, from some of the Wi-Fi that Cisco has for deployment integrated with the cameras, they have it pointed at parks, and they can tell the mood of the crowd. So if they see things getting hostile, they may actually then, let's have police enforcement migrated over this area. And then also, just track people across the crosswalk, zooming in, do the facial recognition.
They do that in malls,
That's great. Yep. All right, well, thank you all for getting back to you about it.